Good evening, this is Mr. Wintermelon. So in the previous chapter, we have learned about how hormones affect our response to changes in the environment. In this chapter, we are going to learn about how our nervous system helps us to react to changes in the environment. So what we have learned about response so far is we have learned about insulin, glycogen, as well as adrenaline, the hormones. For hormonal control, it is usually slow in the response. For example, growth, as well as the change in the blood glucose level, it is not immediate. Sometimes, hormonal control can also be faster. For example,
today in America, it's the twilight of summer. Most 5-year-olds are enjoying their last days of summer freedom or starting school for the very first time. They're talking about superheroes. They're talking about playground slides. But in other places, they're dying. They're surviving. And many, somewhere in between. According to activists, this is Omran. He lives with his mom, his dad, and his brother and his sister. Their home is inside Aleppo, Syria. It was hit by a bomb, an airstrike. Who's behind it, we do not know. He and his family were pulled alive from what's left of their home after being buried in the rubble. Omran is left inside that ambulance, alone, bloodied, as rescuers go back into the rubble looking for anyone else who may have survived. His family did. This comes just a week after the last remaining doctors inside Aleppo. They wrote a letter to President Obama begging for help. Today, the United Nations is asking for 48 hours of relief in the fighting, a break from the violence between the government regime and rebel forces. In 5 years of war, more than 250,000 people have lost their lives. That includes 4,500 children in Aleppo alone. Millions more displaced without a home. Now that includes Omran. And what strikes me is we shed tears, but there are no tears here. He doesn't cry once. That little boy is in total shock. He's stunned inside his home one moment and the next, lost in the flurry and the fury of war and chaos. At least 3 people were killed by this bomb in this neighborhood. This is Omran. He's alive. We wanted you to know.
I can change your mood easily, isn't it? At first, you might be feeling indifferent or happy because just now the picture was quite cute. Now, after watching the news, I'm quite sure any of you who have any heart will feel kind of saddened by the kids that didn't get the chance to go to school. And in some way, I think we should be grateful because you get to learn. But other children are not so lucky. They are born in war. They only know what it is like to live in a war-torn country. So you should be grateful that you can watch Mr. Wintermelon video and learn, because there are many kids that are not as fortunate as you. and you should feel a bit sad for them. This kind of emotional feeling is of course affected by hormone as well. So how does hormones or the lack of hormone make us feel sad? When we are happy, it is actually due to this happy hormone called serotonin. When there's an increase in level of this serotonin, it will make us happy. And when there's a decrease in the level of serotonin, it will make us feel sad. And of course, something must happen that will trigger the lowering of our happy hormone. And this is what we will learn in the chapter of neurons. So what happened earlier on is the image of this boy trigger you to feel sad. But of course, you seeing the image must go through your eyes, then your brain must perceive the image and invoke a sadness. So we are going to learn how all of these are all linked. So what we are going to learn in the chapter of nervous system is of course our nervous system, the anatomy as well as the function. Then we are going to learn about reflex action, the pathway as well as the role of our brain in a reflex action or the lack thereof. We will also go through the anatomy of our eyes because we are concerned with the response of how our eyes react to light as well as focusing. All of these involve our nervous system. So let us start with the anatomy of our nervous system. And you will learn about our nervous system and how they serve to coordinate and regulate our bodily function, and outline the function of sensory neurons, relay neurons, as well as motor neurons. So these three neurons are important. You will learn what are their function. So first off, what are the components in our human nervous system? Over here, we can see a diagram of a brain as well as the spinal cord. So the brain is on top. The spinal cord is the nerve that runs through our backbone. Our backbone is covering the spinal cord, protecting it, because if it's damaged, we will be paralyzed to a certain degree or totally paralyzed, depending on where you injured your spinal cord. So our brain and our spinal cord is known as the central nervous system, or CNS for short. Then you might notice there's branches coming out from the brain as well as the spinal cord. In the brain, we have our cranial nerves. Cranial, that means something to do with our head or brain. The nerves that are coming out from the spinal cord are the spinal nerve. So together, they form the peripheral nervous system. The term peripheral nervous system is not that important. What is important is you need to know that our brain and our spinal cord is the central nervous system. Then there's also other nerves. In the syllabus outline, it mentioned about sensory neuron, relay neuron, and motor neuron. Sensory neuron as well as motor neuron will come under peripheral nervous system, while relay neuron is actually inside our brain and spinal cord. So what is the function of our brain and spinal cord? Our brain is responsible for the integration of information. For example, we look at a maths problem, then we do integration. Or for example, you see a durian, you want to eat it, because your brain integrate the information that spiky green color thing is durian, is delicious, and make you want to eat it. Your brain is also responsible for sense perception, which is a fancy way of saying feelings. voluntary action, which is action that you want to do, for example, watching this video. Your spinal cord is responsible for transmission of information to the brain from the parts of our body that's below our neck, and is responsible for reflex action. What is reflex action? You will learn in the next video. Other important structures in our nervous system is our sensory receptor that receive information, our sensory neurons, relay neurons, motor neurons, as well as the effector. Effector is normally your muscle or your gland that carry out response or action. The function of sensory receptor and effector is down here. They will not test you what is the function, but you will have to know to fully appreciate as well as to answer the question. So if you ask me, do you have to know? Yeah, you have to know, but they wouldn't test you. So what are the roles of sensory neuron, relay neuron, and motor neuron? We will take a look. So let me give you a scenario. For example, you see a fat wolf, or is that a bear? I have no idea, but anyway, it is looking very fierce, it's right in front of you. So that is a stimulus or an input for you to respond to. So we have our stimulus, which is the fat wolf or the thin bear. Our eyes will capture the information through our receptor. Then the receptor will trigger a response in our sensory neurons. Our sensory neuron will send this information to our relay neuron, which is in our spinal cord, and our spinal cord will relay it to our brain, and our brain will say, jialat, scary wolf or scary bear. Then this jialat information will be sent through the motor neuron to the effector, which is in this case our leg muscle, to trigger the response, which is running away from the bear. And other effector might also be affected, which will help to increase the heartbeat and deliver more blood to our muscle. So this is just a quick introduction to how they work. So what are the functions of our neurons? Nerves are made up of bundle of nerve fiber known as neuron. And our sensory neuron is connected to the sense organ. For example, in this case or in the previous case, it is our eyes. The sensory neuron will help to transmit nerve impulse. Another term for nerve impulse is called action potential, from our sensory organ to our central nervous system. So this nerve impulse is actually electrical signal. In your secondary school, they will just say nerve impulse, but I prefer it to call action potential because it is something that have a potential to trigger an action. And when you go university, they will use the term action potential rather than nerve impulse. So just take note of this. You will not be marked wrong if you write action potential. It's more atas. And the problem with writing nerve impulse is sometimes you might write nervous impulse instead, which is wrong. So inside our central nervous system, there's the relay neuron. They can either be found in the spinal cord or the brain. So they are responsible for processing the nerve impulse and make decision. For example, we see a bear. We can actually decide not to run. We can actually fight the bear. So our brain will make the decision of whether to fight the bear or run away. And its function is also to transmit nerve impulse or action potential from the sensory neuron to the motor neuron. Our motor neuron is connected to our muscle or gland, and the function is to transmit nerve impulse or action potential from our central nervous system to the effector, which is the muscle or the gland. And here I indicate that nerve impulse is electrical charges. So information is transmitted through electrical charges in our nervous system. It is different from a hormonal response whereby the information is transmitted by chemical, which is hormones. So this one is important for you to know. So copy this down. So now let us take a look at some common feature of all the neurons. So you will know what are the name of each part of the neurons. So the three types of neurons, sensory neuron, relay neuron, and motor neuron, they contain a cell body which has the nucleus, and this will help them to integrate information. So the cell body of a sensory neuron is here, relay neuron is here, while motor neuron is here. They are not the most difficult thing to identify because you can outright see the nucleus down there. Dendrons, on the other hand, is not so important for your syllabus. What is slightly more important is dendrites, which are tiny branches of dendrons. For them, they are responsible for transmitting impulse towards the cell body. And for dendrites specifically, it will help to receive information from other neurons, then transmit it to the cell body. Axon is the part of the neurons that transmit impulse away from the cell body. Lastly, you will see there are gaps between all the three neurons, and they are known as synapses. Not exactly the most important thing for you to know in your O-level syllabus. What I'm going to teach later is for information to be transmitted across sensory to relay and relay to motor neuron. It is actually not through nerve impulse or action potential, it's actually through chemical. But when they ask you to compare and contrast between a nervous response as well as a hormonal response, you have to say that nervous response, the signal is through action potential, while hormones is through chemical signaling. But honestly, in synapse, it's through chemical. So for nervous control, there's also chemical involved. It's not just action potential or electrical charges. So this is more for your info. Alright? In most neurons, you will find this myelinated sheet. It will help to protect and insulate the axon, and it will help to increase the rate of action potential, which I will explain to you why later, but it's really not important for you to know. In between the myelinated part of the axon is known as the node of Ranvier, and actually that's about all you need to know about node of Ranvier. But some extra information is there's ion channel that allows ion to move in and out of the neurons. For your syllabus, you need to be able to differentiate the three neurons. So this is how. I would say this part you don't really have to copy down because they wouldn't test you on describe the three difference. You just need to be able to identify if they give you picture. So for sensory neuron, the cell body is between the myelinated dendrons and axon. For relay neurons, the cell body is between the unmyelinated dendrites, the highly branched dendrites, and axon, which is also not myelinated. Our motor neuron, the cell body is between unmyelinated dendrites that receive information from the relay neuron and the myelinated axon. So just take note of how different they look and you will be good. Lastly, please take note of this. If you go to university, right, the neurons will actually not be classified as sensory relay or motor neurons. This is just an O-level convention to allow you to have an easier time to understand what are each of their function. So just take note of this. O-level syllabus might not be a true reflection of what is going on in the world. And lastly, let's look at how our spinal cord will look like, as well as some parts which I don't think is that important. So imagine you have a human down here, then you go and chop him into half and take a bird's eye view from the top. You should see his spinal cord will look something like this. So the reason for me to show you this diagram is, in event whereby you need to be able to identify which one is the sensory, which one is the motor neuron, this slide will help you to do so. For the sensory neuron, you can see a cell body down there, as compared to a motor neuron whereby the cell body is inside the spinal cord. So this is how you differentiate the sensory neuron from the motor neuron. So actually this is all for this video. I will add in some information after this, because if you ask me, it's actually a bit sad that other knowledge is not being taught to help you to understand the working of our nervous system. And if you go to JC, they have taken nervous system out of their syllabus. So the next time you come into contact with nervous system is maybe in university, year 3 or year 4. And even then, it's probably an optional topic. So actually many teachers might not be qualified to teach what I'm going to share later on. So how are the signals being transmitted in our neurons? As I have mentioned, inside the neurons is transmitted through electrical impulses or cation, which are positively charged ion. That is why we say that it's transmitted through electrical charges, because cation, they have electrical charge. There is also chemical signaling through neurotransmitter, and this occurs in the synapse. You can imagine neurotransmitters something to be similar to hormones. They are chemical molecules, just that they are not transmitted through the blood and not released by gland. They are released by the end of the neurons. So for electrical impulse, as you can read, is the influx or the entering of positive ion. And I will show you an animation of this. So imagine you have your neuron down here. Then there's channel that are in blue, as well as ion, cation, that is surrounding the neurons. The gray color parts are the myelinated sheath, and you can see why they will help to speed up transmission of action potential. So let's say there's an influx of ion. So those channels at the node of Ranvier, they are actually a special type of membrane protein. They are known as voltage-gated channel, because they will remain closed when the voltage is low. But once there's some influx of ions or cations, the charges in the area will increase. Once it is increased beyond a certain threshold, the voltage-gated channel, they will open. So once this voltage gated channel opens, the ion will flow in. And when this happens, the charge in that part of the neuron will increase even further. And once it reaches the peak, the channel will close down. The other channel, it will open up since the voltage at that area has increased. And what will happen is the same as before. Ions will flow in, but at the same time, the cation on the left side of the channel, it will be pumped out to the surrounding. So you might not have catch it. Let me repeat again. So this is the second channel. Cation will rush in, while the cation at the left, they will be pumped out. So in this way, the action potential will only travel in one direction. Because once the voltage increases beyond a certain level, the channel will close. And the channel ahead, they will open. And the same thing will happen. Cation will flow in, while the previous cation will be pumped out. So the pumping out channel I did not include down here, but there are also channels that are responsible for pumping the ion out. So in this way, the action potential will be in one direction. So the myelinated sheath will speed up the rate of the propagation of our action potential because the channel can be more spaced out from one another, allowing the influx of ions to be further. Since the voltage gated channel will close, when the charge inside the part of the membrane they are close by reach a certain level. So if they are placed one beside the other, the flow of cation will be very slow because they will open and close very slowly. Unlike in this case, they are spaced out and the ion have more room to flow. So after the action potential reached the end of the neuron, it would have reached the part where we call synapse. So when the action potential arrives at the terminal or the end of the axon, neurotransmitter will be released. Neurotransmitter will diffuse across the synapse and bind to the receptor at the next neuron. This binding will open ion channel again and the ion will flow in, the membrane potential will increase or the charge in the membrane will increase and this impulse will be carried forward. There will be some enzyme to degrade the neurotransmitter and the channel will close and impulse will stop being generated. And here I have a simple animation showing you how it works at the synapse. So what happens is nerve impulse will be transmitted to the end, then the neurotransmitter will be released, channel will be open and impulse will be carried forward. And this will be all for this video. And do take note that the information at the end is really not necessary for your O-level syllabus. But I hope that these have helped to improve your understanding of how action potential is being transmitted in the neuron. And this is very interesting, so you should read it up more on your own.